That is a classic, hyper-creative Australian shed engineering workaround. You are effectively talking about building a custom air-flushed DTH down the hole hammer bit using a donor SDS head. Your logic is mathematically sound. An EDM hole popper, electrical discharge machining, uses high-frequency electrical sparks to erode a hole through any conductive material. It will easily zip a 2 to 3 millimeters airflow hole straight through the hardened steel core of an SDS bit, bypassing the ultra-hard tungsten carbide insert completely. While this setup is entirely possible to construct, executing it successfully requires navigating three critical mechanical failure points. 1. The EDM hole location. Do not try to drill the air holes through the tungsten carbide insert itself. The thermal shock from the EDM spark process can microfracture the cobalt binder inside the carbide, causing the tip to shatter the moment your rotary hammer starts pounding the FNQ granite. The fix. Use the EDM to pop two small angled holes into the steel shoulder right beside or underneath the crosshead wings, angling inward to meet the hollow internal cavity of your custom drill rod. 2. The brazing joint. The shock factor. This is where the project faces its highest risk of failure. Turning a 50mm spigot on the back of the cut-down SDS bit and pressing it into your hollow tube creates a joint that must survive incredible impact forces. Standard workshop silver solder, like EasyFlow, will crystallize and shatter within 2 minutes under an SDS hammer action. The metallurgy. Tool factories braze carbide tips at over 1100 degrees Celsius using specialized copper manganese nickel or heavy nickel bronze brazing alloys. These alloys act like a shock-absorbing cushion between the metals. The fit your machined joint needs to be an incredibly tight press fit. If there is even a fraction of a millimeter of slop inside that hollow sleeve, the repetitive hammering action will shearing the brazing alloy apart, causing the head to detach inside the hole. 3. Air volume versus dust packing. Because you are drilling hard granite, the dust produced by a 4X bit is a microscopic, highly abrasive powder. If your EDM air holes are too small, e.g., 1.5 mm to 2 mm, you will need extremely high air pressure, over 100 psi, to force enough volume through them to lift heavy granite dust up out of a 10 mm to 20 mm hole. If the air volume drops even slightly, the dust will instantly settle, pack tightly around the outside of your custom hollow tube, and seize the drill bit permanently in the rock. Summary checklist for success. If you have access to a lathe, a high-temp torch, and an EDM hole popper, this makes for an incredible custom tool project. To give it the best chance of survival against that Herbert and Stone. 1. Machining. Turn the spigot on the back of the SDS tip to a tight interference/press fit inside your hollow rod. 2. Brazing. Do not use soft plumbing or standard jewelry silver solder. Buy a specialized high-temperature nickel bronze or manganese brazing rod and high-temp black flux. 3. EDM. Drill your flush holes through the steel section of the tip, never the carbide, and keep them as large as structurally safe to maximize air volume.